All right, I'm going to go over the work we did in class relating to Euler's number, or E. Now, this number is an approximation. You can't get an exact value of it because it's a number that goes on forever. And we're going to talk about why this number is important, particularly to calculus, later, because we've got to do the derivative. But the number is 2.71828, and it goes on. And like pi, we already said it's irrational. Now, Leonhard Euler, this is the number that he didn't, or did he discover it? Yes, people knew about it, but he was one who really put it on the mathematical map. So it's a transcendental number, which means it's irrational, but it's not absurd. It was proven by this gentleman, Charles Hermite, in 1873, and then that Leonhard Euler gave E its symbol. He gave an approximation of E to 23 decimal places, and now it's been calculated to huge amounts. So Euler gave mathematics heaps of other stuff. So we've got the symbol for pi, the square root of -1, the symbol sigma for summing, and f of x for notations. Now, the first thing you need to be able to do is sketch these curves. Now, we've been doing exponentials, but these other ones, remember that E is a number. It's approximately pretty close to 3, 2.718. So sketching it is not hard. So let's have a look at 10.2. Now, I'm just going to get myself there we go, set of axes. And remember, whenever I'm sketching these, I've got to remember what's going to happen. Well, that 2 is going to make it steeper. And if I put something with the x, it's going to move it. Now, if you ever get confused about where it's going to move it to, just think, what do I need to do to make that equal 0? To make that equal 0. And I have to put x equals 2, which means I'm going to move it 2 to the right. So if I go over here now and I look at my curve. Now, forget about the 2 for the moment. Imagine if I just had, come on, give me my colours, thank you. Imagine if I just had y equals e to the x. Y equals e to the x would go through there at the point 1. And if I pushed it 2 to the right, that would put it there. It'd still be the same curve, but it'd be going there. And this would be 2, and that would be 1. Now, that's if that is y equals e to the x. Oh, hold on. If that is y equals e to the x. And this is y equals e to the x minus 2, or 2 minus e to the x. Sorry. E to the 2 minus x, which is what we've got. But, it is x minus 2. Sorry about that. X minus 2. But we've got a 2 in front of it. So what does that do to this thing? Well, it's going to make it steeper, but also it's going to change what happens when x is 2. So if in doubt, you can type it in on your calculator. So 2 times, now to get E, you just go shift and over here to the LN button, and you get E. And we want to the 2 minus 2. We want to find out what happens when x is 2. When we hit return, it's 2. So it's moved it up 2 spots, so it's there. So let's get rid of these on that one. And we know that, and we don't really need to worry that that's 2. But we do need to find out what happens. We do need to find out what happens when x equals 0. So let's put x equals 0 in there. So we just use our back arrow and put 0 in. Now that's the y-intercept. When x is 0, we get the y-intercept. So it's 0.27. So about here is 0.27. Now the other thing we want to find out is what happens is as this curve comes down there. So when x is a really big negative number. So let's just go back and put -10 in there. And it's getting very close to 0. Let's put -100 in there. It's getting very, very close to 0. Let's put 1,000 in there. It tells me it is 0. It isn't. It doesn't touch 0. 0 is a limit. It's just got so close to it that the calculator won't write all the numbers. So now we know that. I'm going to put my asymptote in here. I'm going to put in green, asymptote. There it is. And I'm going to draw my graph. And there is y equals 2e to the x minus 2. So the basic shape stays the same, but you've got to get the intercept, and it's really, really good if you can get this point here, it's going to be 2, 2. All right? And it gives you an idea of size. And you should always label your axes, and you should have your asymptote. Now, I'm not going to do question 2. You just plug them into your calculator. As I said before, to get e to the power, you have to press Shift and ln. And you can see it's there. If you just want e, you can go alpha and down here, and it'll just give you e. And if you press equals, it gives you that. But my suggestion would be to use a Shift and use that one over there. Now, all you need to be able to do is sketch these functions. So let's go back, and we've got to sketch a couple of functions. So I'll get this again. I'll draw a couple of these. And another one. Move that up there. There you go, that'll do us for now. Because you're going to be able to do these. These are not too hard. So, the first one, y equals 2e to the x. So that's just going to be a standard one. It's going to go through there. But remember, you need the asymptote. I'm going to do it in purple this time. The asymptote. Now, see if you can do this bit on your own. What's going to happen when x equals 0? Well, you're going to get e to the 0, which is just going to be 1. And you're going to get 2 times 1. So that's a value 2. Put your label your axes. Label your function. Y equals 2e to the x. Now, what's the next one? E to the x plus 1. Well, what is that going to do? That's just going to move everything up 1. So 1, 2. So it's going to go up there. But be careful. The asymptote is down here at... show me my tools again, thank you. This is down here at 1, because the whole thing's moved up 1. So my curve looks like that. Y equals e to the x plus 1. It's just the whole curve moved up 1, and that's 2. And everything moves up. And again, there we go. There we go, y and x. Finally. And I'm going to do all these ones, these next ones, on the one graph. So, I'm going to make it a big one. That'll do. Move it over to here. That's y, and that's x. Excuse me. And what am I going to do? The first one, y equals, now, I'm going to draw y equals e to the x. Y equals e to the x. I'm going to draw that in red. There it is. There's y equals e to the x. Now, negative e to the x just flips it, and it flips it in the axis below, so in the x-axis. So it's going to be there, -1. That's y equals negative e to the x. And they have that same asymptote. Now the next one, e to the negative x. Well, that just, and by the way, that's at 1. So let's go blue, and I've used blue, let's go green. This one just flips it there. And that's y equals e to the negative x. Now a double flip, and this is what we did last time, you can do it, a double flip, this one here. Well, I'm just going to flip this blue one in the y-axis. I'm just going to flip it, I'm just going to make it, let me see, let's go purple, oh, no, orange, righto. So that is just going to flip here. All right, and that's your y equals negative e to the negative x. Now the rest of them are pretty standard. You have to go and apply yourself to those, but that's the hard ones, the sketching ones. All right, good luck with those.